What existed before the Big Bang? This may be the most boundless question of human thought, but what do we mean by nothing? Emptiness? Darkness? No, those are still something. True nothingness is a state where not even time existed. No matter, no energy, no space, literally nothing. We, as humans, find it incredibly difficult to imagine a true absence. Our entire perception of reality is built upon things, objects, sensations, time flowing forward. So when scientists speak of nothing, they refer to an absolute void, a state where not even the laws of physics, as we understand them, applied. In this pre-universe state, there was no up or down, no here or there, only a complete absence of being. That is perhaps the most mysterious and difficult concept the human brain can attempt to grasp. Yet science dares to venture into this void, not to fill it with assumptions, but to understand how something could arise from it. What mechanisms could lead from non-existence to existence? What caused the birth of the universe? According to scientists, the Big Bang wasn't simply a gigantic explosion of material into space. It was the very creation of space and time themselves. That's why asking when it happened or where it occurred becomes meaningless. There was no before and no outside. Everything began then. Approximately 13.8 billion years ago, our universe was compressed into a state of unimaginable density and temperature, a singularity, an infinitely small point where all the laws of physics as we know them break down, and then expansion. Not an explosion in the conventional sense. There was no air, no sound, no light, but the fabric of space itself began stretching outward, expanding faster than the speed of light. From that singular moment, all that exists, time, space, energy, and matter, was born. And with it, the potential for everything: galaxies, stars, planets, life, thought, emotion. The instant of creation was not a random event. It was the ignition of the very framework of reality. In that one singular burst, the entire cosmic code was seeded. Physicists call this moment the birth of the observable universe. But it's important to understand how little we still know about what happened in the first fractions of a second. Our most advanced theories, like general relativity and quantum mechanics, can't fully describe what happened at the singularity. That's why modern research explores ideas like quantum gravity, string theory, and loop quantum cosmology to fill in the gaps. The very first second of the universe's existence was wildly chaotic and extraordinarily fast-paced. Even with today's most advanced physics, we can only sketch a rough timeline. At 10 to the negative 43rd seconds, known as the Planck time, the force of gravity separated from the other fundamental forces. This was the first detectable moment of physical reality. At 10 to the negative 36 seconds, inflation began, a mind-blowing exponential expansion of the universe, faster than the speed of light, causing the cosmos to balloon from subatomic size to macroscopic scale in a fraction of a moment. At 10 to the negative 32nd seconds, inflation ended and the universe reheated. Temperatures soared, and particles began forming in staggering numbers. At 10 to the minus 12 seconds, the electromagnetic and weak nuclear forces split. At 10 to the minus 6 seconds, quarks formed and began binding together to become protons and neutrons, components of the atomic nucleus. These are unimaginably brief moments, yet they were the most crucial phases in the formation of the universe's structure. These time frames are measured in trillionths of a second, but each brought forth entirely new phenomena. Think of it as the ultimate symphony, a composition written in the language of physics, with gravity, energy, and particles acting as its notes. At around 1 second, a massive event occurred: the annihilation of matter and antimatter. But miraculously, there was slightly more matter than antimatter, just enough for everything we see today. This tiny asymmetry is the reason we exist. Had they been in perfect balance, the universe would be void. No stars, no galaxies, no life, no you. This imbalance is one of the greatest unsolved mysteries in physics. Why did the laws of nature favor matter over antimatter? Scientists continue to investigate through experiments like those at CERN's Large Hadron Collider, hoping to uncover the deeper principles behind this life-creating inequality. In those early moments, the universe was an ultra-dense plasma soup of particles and energy. Light couldn't travel freely. It was constantly bouncing off free electrons. It took nearly 380,000 years for the universe to cool enough for atoms to form. This event, called recombination, made the universe transparent, and light, finally, escaped. It's called the cosmic microwave background, a faint, ghostly glow, the first light of the cosmos. It's the baby picture of the universe, frozen in time. Like the first photograph ever taken, this radiation gives us a snapshot of the universe just 380,000 years after its birth. It's not just a beautiful image, it's a time capsule. Slight fluctuations in that radiation reveal the seeds of galaxies, imprinted like fingerprints of the early universe. Cosmologists have used this data to map the shape, age, and even the ultimate fate of the cosmos. As time passed, hydrogen and helium atoms clumped together under gravity. They formed vast clouds, and those clouds gave birth to the very first stars. These ancient stars, called population 3 stars, were massive, hundreds of times the mass of our sun, and lived short, brilliant lives. These stars forged heavier elements in their cores: carbon, oxygen, iron. When they died in colossal supernovae, they scattered these elements across the cosmos. This process, known as nucleosynthesis, is the very reason we have the periodic table. Without these ancient explosions, there would be no iron in our blood, no calcium in our bones, no oxygen in the air we breathe. Galaxies formed. Solar systems emerged, and within one small corner of a spiral galaxy, roughly 4.6 billion years ago, our sun was born. Around that sun, planets coalesced, one of which was Earth. On Earth, under just the right conditions, life began. Initially as simple single-celled organisms, evolving slowly into multicellular creatures. Then, across the eons, consciousness emerged. Beings who could look up at the sky and ask profound questions. Where did we come from? Why are we here? What lies beyond? And here you are. Watching this video, a conscious spark born from billions of years of cosmic evolution. From stardust to self-awareness, your very existence is the product of an ancient chain of events stretching back to the first instant of time. But the story doesn't stop here. The universe continues to expand. Not only that, it's accelerating. Something is pushing galaxies apart at increasing speeds. Scientists call it dark energy, though we don't yet know what it truly is. It's as if the universe is being driven apart by a mysterious force that defies gravity. In fact, dark energy makes up about 68% of the universe. Another puzzle is dark matter, an invisible form of matter that doesn't emit light or energy, but reveals itself through gravity. Galaxies rotate faster than they should, and only dark matter's pull can explain why. It accounts for about 27% of the universe. That means everything we can see, stars, planets, nebulae, makes up less than 5% of all that exists. You might ask, how can we possibly know all this? The answer lies in observation, mathematics, and evidence. In 1964, scientists Arno Penzias and Robert Wilson accidentally discovered the cosmic microwave background, a faint signal that matched predictions made by the Big Bang theory. This discovery earned them the Nobel Prize. Since then, countless other observations, the structure of galaxies, the abundance of elements, the stretching of light from distant galaxies, called redshift, all continue to affirm the Big Bang model. But even with all we know, huge mysteries remain. Will the universe expand forever, cooling and dimming into a big freeze? Will everything reverse in a cataclysmic big crunch? Or could quantum fluctuations trigger a big rip, tearing apart all matter and even space-time itself? Some scientists propose even more mind-bending ideas. What if our universe is just one of many in a grand multiverse? universe? What if Big Bangs are constantly birthing new universes beyond our reach, each with different laws of physics, different dimensions, different possibilities? These aren't just questions of physics. They are deeply human questions. They touch something spiritual in us, because understanding the cosmos is, in a way, trying to understand ourselves. We are not separate from the universe. We are a part of it, made of the same elements as stars, born from ancient stardust, connected through time to the very first spark of creation. And every conscious soul must realize that behind all of this, there is a creator, a force that is Rahman, the most merciful, and Raham, the most compassionate. That creator is Allah. To reflect on the origin of the cosmos is to reflect on our own origin. And when we ponder the vastness, the beauty, the precision, we see signs everywhere. Signs not of chaos, but of meaning, not of accident, but of intention. If you enjoyed the video, don't forget to subscribe to the channel and hit the like button. I'll be eagerly waiting to read your thoughts in the comments. Stay tuned to the Future Bound channel.